Hi folks, we're going to take a look at an example of drawing the graph of a function given its derivative. All right, so here again I chose something that was a little more interesting than just a polynomial looking function. So let's start from negative infinity to this vertical asymptote here. So again, what we have to keep in mind is what these y values for the derivative give you are the slopes of the tangents to the original function. It doesn't tell you anything about the y values of the original function. So we have to keep that in mind, that we're going to have to make some choices as we go along. So here, I notice that the derivative is equal to 0, which means that the original function is going to have a horizontal tangent at that point. All right, and let's see what's happening to the derivatives to the left and right. I see that to the left, the derivatives are positive, and to the right, the derivatives are negative. Okay, so what's going to be the behavior of the function? Well, in order for the slopes to be positive, I know the function is going to be increasing. Okay, and then once you get past this 0, the slopes of the derivative is negative, so the slopes of the tangents are going to have to be negative, so the function is going to be decreasing. But again, what I don't have is what the y value is going to be. So I'm going to just pick some random y value here and say, so it looks like it's about there. There you go. I'll pick that as the y value. Okay, I could have picked something higher, I could have picked something lower, but that's what I chose. Okay, so again, remember what we said. Since the slopes of the tangents are positive, I know that the function is going to be increasing here. Okay, so it looks something like this. And we see that as I move to negative infinity, they're getting steeper and steeper and steeper on the positive side. So that's why it's approaching positive infinity. Okay, and then here, it's negative and getting more and more negative. So in terms of the function, it's going to be decreasing, and the slopes of the tangents are going to be getting steeper and steeper and steeper. So I've got something that looks like that. All right, so let's move to the right-hand side of the vertical asymptote. So again, I see that the slope of the tangent is going to be 0 here. Okay, but now look at what my derivative is doing. It's going from negative to positive. So I would expect it to be going from decreasing to increasing. Okay, but again, this doesn't give me any information about what the y value is. So I'm just going to pick something random. Okay, so I make it negative this time just to change it up. So what did we say? It's negative and getting more negative as I move to the left. So it means that this is going to be going up and approaching positive infinity, because you see it's getting more and more negative as I move towards the vertical asymptote. Okay, so let's see what happens now to the other side. Here I see that the derivative is getting more and more positive up until this point, somewhere there. Okay, then notice the derivative is still positive, but getting less positive. Then get to this point here. Derivative is still positive, but getting more and more positive. Okay, so again, we have to figure out what does that mean in terms of how the function behaves. So looks like up until this point here, and I'll draw a dotted line just to kind of give me, to kind of know where to go. I'm going to see that the function's tangents are going to get steeper, 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 steeper. Okay, but then somewhere around this point, they're still going to be positive, but getting less steep. So look at how I'm going to draw the function. I'm going to draw it so that the tangents are getting less steep up to around there. Notice they never get to 0. And then what happens at this point? They start getting more and more positive, okay, till I get to this value here. Okay, so you see getting steeper, okay, here getting less steep, and then here getting steeper. And I'm going to try to draw this so that it's nice and curvy, because the derivative exists there everywhere, so the best that I can. But then look at what happens. Okay, the derivative doesn't exist at this point. So it means we've got something interesting going on at this x value. It could be a jump, could be a hole, could be a vertical asymptote. Let's see if we can figure out what's going on. Well, remember that just because the derivative exists doesn't tell me that the function doesn't exist. Okay, but I notice that the derivative goes from positive to negative. So I think what I'm going to have here is going to be a cusp, because here I had something that had a positive slope, and now all of a sudden it's got a negative slope, so it's going to be decreasing. So it looks like I'm going to have a cusp. And let's see what's happening to these derivatives. They're negative, but they're approaching 0. meaning that the slopes of the tangents should be getting flatter and flatter and flatter. So it looks like I probably have something that's going to look like this, where the derivatives, okay, are negative, but getting less and less negative and approaching zero. All right? So just to recap here, first of all, a reminder that the derivative tells you nothing about the y values of the function. It just tells you about the slopes of the tangents. So here I saw that I went from negative to positive with a 0. So, sorry, from positive to negative. Sorry about that. So from positive, 0 to negative, getting more and more negative. Here we went from negative to positive, so negative to positive. But here we got getting more positive, so steeper, 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 less positive, less steep, okay? Getting more positive, steeper, 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 and then we get to a point where the derivative doesn't exist. And we see that the slopes of the tangents went from positive tangents to negative tangents approaching zero. All right, that's it for this one.